To some people, insects are seen as gross, scary, or maybe even irrelevant. However, what if I told you that many of the systems and designs we use today are inspired by insects? Let's look at the idea of insect biomimicry. How do insects inspire innovation? You may be wondering, what even is biomimicry? According to the Biomimicry Institute, biomimicry is a practice that learns from and mimics the strategies found in nature to solve human design challenges. One of the most popular examples of this is the inspiration from sunflowers to create solar panels that follow the sun in order to maximize solar absorption. But insects have also inspired many different designs that range from water collection systems to self-ventilating buildings. So why is nature such a good inspiration for so many designs? According to Interface, the Earth has been adapting to whatever challenge it has been presented for 3.8 billion years. These adaptations have forced organisms to evolve characteristics that solve issues and make them as efficient as possible. Nature is basically the CEO of solving design issues. If we didn't copy ideas from nature, things that seem so simple to us now would not even exist. Things like Velcro or umbrellas. The first example we will look at is the rose butterfly and solar panels. The solar-absorbing wings of the rose butterfly have inspired scientists to mimic this in solar panels. A study published in Science Advances says this butterfly has black, pigmented wings that are made of micro and nano-structured scales. These different sized scales help absorb sunlight at many different angles. The biology of this wing inspired a much thinner solar panel that includes different sized micro and nanostructures. Other solar panels are built at the incident angle where it is able to absorb the most sunlight. However, in a study published in the Journal of Science Advances, solar panels with this biomimicry design were able to absorb 90% more sunlight at a normal incident angle. For our second example, a man named Mike Pierce was the architect hired to design the Eastgate Center in Zimbabwe. According to Joanne Klein of the New York Times, this building is 350,000 square feet and inspired by the self-ventilating mounds of dirt made by termites. Termites are tiny eusocial insects that build mounds up to 30 feet high. These mounds are able to maintain a temperature of about 30 degrees Celsius even when the temperature on the outside of the mound is fluctuating dramatically. The mounds are built with tiny pores that allow oxygen to enter and CO2 to exit. Similarly, the Eastgate Center uses fans that are set on a cycle that allow heat to be stored during the day and released during the evening to heat the building. Rooftop chimneys allow hot air to rise throughout each level and exit the building. There are also other openings throughout the building that mimic the pores in a termite mound. By designing the building to mimic termite mounds, energy costs were decreased and there was no need for other ventilation systems, resulting in a savings of $3.5 million. Compared to neighboring buildings, the Eastgate Center uses 90% less energy. Thirdly, the Namib desert beetle lives in a very dry climate, but it is able to use fog as a source of water. According to an article published in Science Direct, this beetle's elytra are covered in hydrophilic bumps that allow water droplets to attach on and travel down to the beetle's mouth. These beetles collect fog by fog basking, which is a process that involves facing away from the fog and tilting its head downward so the collected water can run down into its mouth. These hydrophilic bumps have inspired the creation of the dew bank bottle. This water collection device is set outside at night and collects morning fog by condensing water on its surface. This device has different sized bumps like the Namib Desert's elytra, allowing more water to attach to it. This invention is very useful for people who live in desert areas with little access to clean water. Fourthly, different species of ants follow different patterns of ant colony optimization. They use strategies to transport food around their colony. According to Liv Scott of the Biomimicry Institute, Mexican ants have one permanent nest where food is brought back after the ants fan out to find food. The Argentine ant does not have a permanent nest and instead nests in temporary spots during their journey to find food, joining new groups of ants throughout the process. A food hub in Ohio brings produce from small local farms together and supplies large quantities of fresh produce to schools, restaurants, and grocery stores. These local farmers were spread out all across the region, making the founders of the food hub travel all over to deliver and pick up produce, decreasing the efficiency of the company. To deal with this issue, the food hub took an Argentine ant approach. This inspired the creation of Farm Fair, which is a network that connects all food hubs together to allow them to advertise available foods to each other. This allows each hub to purchase in bulk from other hubs, instead of focusing on one central hub, like the Mexican ant approach would. This new strategy helped the sustainable food system in this area by allowing them to compete with larger wholesalers and pay local farmers a better wage. According to a study published in Science Direct, Dragonflies are excellent flyers because of the structure of their wings. They are able to hover and move forwards and backwards very quickly, helping them both catch prey and escape from predators. A dragonfly's wing is very light and aerodynamic, yet very stable at the same time. This is due to a number of characteristics such as the change in thickness from the tip to the root of the wing. The wing is also covered by a waxy layer that supplies more stability and also keeps the wing dry by making it more hydrophobic. A dragonfly's wing is corrugated, which allows the wing to be more elastic and actually deform during use, improving their ability to change flight direction quickly. Although a dragonfly's wing is incredibly thin, there are different nanostructures that enhance their impressive flying abilities. These wing characteristics were used in planning a more efficient and faster BMAV, or more commonly known as a drone. These devices are flown from the ground, so it is important that they are easy to maneuver. A study published in the Chinese Journal of Aeronautics worked on creating a wing with the same elasticity and structure as a dragonfly's wing. This would increase the range of motion and speed of the drone. According to Dennis No, a very early example of biomimicry was inspired by a caterpillar's unique body. A caterpillar holds onto surfaces with the use of prolegs. These act as hooks under their body and allow them to climb on the underside of leaves. Their body is also segmented, allowing more flexibility and movement. Benjamin Holt was the first to use the caterpillar as inspiration for tank tracks during the 19th century. The prolegs on a tank's tracks are called shoes and allow it to move across steep surfaces. The tracks are also segmented like a caterpillar's body to allow one continuous track to rotate around the structure, adding to its ability to balance. As climate change continues to change our ecosystems, biomimicry will be a strategy that many designers will rely on to create a healthier Earth. Insect biomimicry has the ability to improve existing technology like solar panels or invent new products like the dew bank bottle. As we move into the future, we will see more and more designs inspired by insects and other elements of nature. Let's work together to protect nature because it has spent billions of years evolving into the essential and inspirational planet we call home.